Welcome back to Chem Sleeping Lab, episode 3. In the last 2 episodes, we talked about what a chemical is and what states it can be in. Tonight, we will talk about why things burn. What is fire? Fire is not a solid. It is not a liquid. It is not a gas itself. Fire is what we see when a chemical reaction is happening very fast and it gives off heat and light. The name of this reaction is combustion. Burning is combustion. In combustion, a fuel reacts with oxygen in the air. This reaction releases energy. That energy comes out as heat, which you feel as warm, and as light, which you see as flame. Most fuels are made of carbon and hydrogen. Wood, paper, gasoline, ethanol, natural gas. They all contain carbon and hydrogen. When they burn in enough oxygen, they turn into two main things: carbon dioxide, CO2, and water, H2O. The same two gases we breathe out. So fire is a chemical change. The starting materials are gone and new materials are made. It is different from the phase changes we talked about last time. When ice melts, it is still water. When wood burns, it is no longer wood. Combustion also needs to be fast. Rusting is also iron reacting with oxygen, but it is very slow, so it does not make flame. Fire is the same type of reaction, but much faster. Almost all combustion needs to be started. Wood does not just burn by itself in a normal room. It needs heat first. Which brings us to the most famous model in fire safety. To make a fire, you need 3 things at the same time. We call it the fire triangle. Side 1 is fuel. Fuel is anything that can burn. It can be a solid like wood and paper. It can be a liquid like gasoline and ethanol. It can be a gas like propane and hydrogen. Fuel is the chemical that has energy stored inside. Side 2 is oxygen. In most fires, the oxygen comes from the air. Air is about 21% oxygen. That is enough for most things to burn. If oxygen is lower, fire becomes weak or goes out. That is why a small fire in a closed box will go out by itself. It uses up all the oxygen. Side 3 is heat. Heat is the energy needed to start the reaction. We also call it ignition source. It can be a flame, a spark, a hot surface, even static electricity. If any one side of the triangle is missing, there is no fire. This is very useful for safety because it tells us there are 3 ways to prevent a fire. Remove the fuel, remove the oxygen, or remove the heat. In a lab, we try to do all 3. We keep flammable liquids in a closed metal cabinet that is removing fuel from the open air. We work with a fume hood to remove flammable vapors that is also removing fuel. We keep all ignition sources like open flames and hot plates away from the fuel that is removing heat. Risk equals hazard times exposure. Here, fuel is the hazard. Heat is what creates the exposure. Sometimes you will see a model with 4 sides. Triangle plus 1 more. And the 4th side is chain reaction. When fuel burns, it makes heat. That heat makes more fuel vapor come out of the fuel. That new vapor mixes with oxygen and burns, making more heat, which makes more vapor. It is a chain, a circle that keeps itself going. If you break the chain, the fire stops. Even if fuel, oxygen, and heat are still there. Some special fire extinguishers work by breaking that chain. Now, 2 small concepts that help you understand liquids better. The first is flash point. Flash point is the lowest temperature at which a liquid gives off enough vapor to form a flammable mixture with air near its surface. It is not the temperature at which the liquid itself burns. It is the temperature at which its vapor can flash if there is a spark. A low flash point means the liquid is more easily flammable at room temperature. For example, gasoline has a flash point around minus 43 degrees Celsius, very low. So, At room temperature, it always gives off enough vapor to burn. Ethanol has a flash point around 13 degrees Celsius, also quite low. Diesel has a higher flash point, around 62 degrees. So diesel is less easily ignited than gasoline at room temperature. The second concept is flammable range. For a gas or vapor to burn, it needs the right ratio with air. Too little vapor in air, too lean, it will not burn. Too much vapor in air, too rich, it will not burn either. Only between those two limits will it burn. We call it lower flammable limit and upper flammable limit. So how do we stop a fire? We just remove one side of the triangle. Remove fuel, we call it starvation. Close the valve of gas, remove the paper, move the flammable liquid away. Remove oxygen, we call it smothering. Cover the small fire with a lid. Close the door of the room. Use a fire blanket. Without oxygen, fire cannot breathe. Remove heat. We call it cooling. The most common way is water. Water takes away a lot of heat because it takes a lot of energy to become steam. So water cools the fuel below its burning temperature. For breaking the chain reaction, we use some dry powders and special gases. They interrupt the chemical reaction itself. In a lab, you will see different fire extinguishers for different fires. But as a general user, you do not need to memorize them now. Just remember two habits. Habit 1, keep fuel and heat apart. Do not charge your phone on your pillow. Do not place ethanol near a stove. That is controlling exposure. Habit 2. If a small fire happens and it is still very small, like in a pan, you can smother it with a lid. If it's bigger than a pan, leave the room and call for help. Your safety is always more important than the object. Fire needs all three sides of the triangle. Safety is about never let all three meet. Now, let's review tonight. Fire is a fast chemical reaction between fuel and oxygen that gives off heat and light. It needs three things: fuel, oxygen, and heat, the fire triangle. How we understand flash point and flammable range helps us understand why some liquids are more hazardous than others, and it is the vapor that burns. And how we stop fire is to remove one side of the triangle. That is all for tonight.